I won. Today our lesson 2014 Newton's law, right? Today our questions 2014 A level second paper 12A Newton's law, right? Newton's law. Uh, First, just read that question, okay? Right? The triangle ABC in the given figure represent a vertical cross section to the center of gravity of a uniform smooth wedge, right? This is the wedge questions, right? Now you have new syllabus, you have wedge and pulley, right? That is a combined questions after 2019, but this is the 2014 uh, only wedge questions, right? Uh, of mass M, capital M, the line AB is a line of greatest slope, right? Uh, of the face containing it ABC alpha, ACB by 2, and BC equal A. That is given, right? Everything given. The wedge is placed with the face containing BC on a smooth horizontal flow, right? That is given. Everything given in figure, right? Uh, a particle of mass M is gently placed on the line AB at a point A, right? That is special thing, right? Point A, right? And release from rest, right? That's also special, right? So that until the particle leaves the wedge, right? The acceleration of the wedge is that is given, right? Uh, mg sin alpha cos alpha divide capital M plus simple M sin square alpha, right? We have to find that one, right? First thing we have to find what is that acceleration of particle, no? Acceleration of particle, right? I think that is relative to Earth, right? Not wedge, right? We have to find the acceleration of particle relative to Earth, right? Okay, sometime some student find that that particle acceleration they have to find wedge, right? Right. First thing, we can clear this type of diagram, right? That should be bigger than to given that, right? B, C and A here, 90 degrees here. Given that particle here, but we should place on here. Why? That is moving, no? That is moving. Is a here starting point and here ending point, right? We have find the moving. This is the reactions are particle P, I think, no? Not P. Right. We can place on P here and here mg, which also capital mg, and this is the reaction S. That is forces are here, right? These are the forces. You have to place on like that, right? Now we have another special thing. What is that? Acceleration, right? That is acceleration we have. Before the place acceleration, right? Before the place acceleration, you have to find any reactions are correct, right? Mg, that is downside, right? Okay, that is correct. That Mg, that also correct. And reaction is complete, right? Here both are complete. What is that? These are reaction to P, that particle. These are, that is to wedge, right? That is from Newton third law, no? Right? Newton third law, right? No need that one, right? Now we have acceleration. We have to find acceleration of wedge, no? That is the special thing, right? Then we think about that is goes to like that capital F or simple of something. I am placed that F1, right? Sometime meaning any symbol, right? Normally we are using F and F1 here. Then this one also have F1 here. These two wedge, right? And this one relative to wedge F2. We can place F2, right? That diagram is complete, I think, right? Here alpha, right? This is the alpha here, and I think that is the complete, right? Now complete. We have another thing here is starting 0 and this one have velocity after that, right? First answer we have to this one only, right? Enough that, right? Now second thing, diagram complete, right? Diagram complete only for first answer. Another one, second answer here, but this one complete for first answer, right? Now we are going to relative acceleration theory. Why? We have to find that acceleration of P, right? Previously I mentioned that one, no? We have to find acceleration of P relative to Earth, right? We have to find acceleration relative to Earth, right? That is the case, right? We can say here, no? Right. From relative acceleration theorem. What is that? If, that is the vector, if particle P relative to Earth, and if P relative to M, that is the wedge. If wedge relative to Earth, P relative to wedge, P relative to wedge, F2. Here alpha, this one also alpha, right? What is the angle? Alpha horizontal, F2. Wedge relative to Earth, what is that? This one or this one? Here F1. That is complete. No need to any calculation for that. That is complete, right? Right. Relative acceleration theory, finish, right? Now we have another one. We have to find F1, F2, something that, right? What is the next one? Newton second law, right? Newton second law. What is that? First thing, P. We are using Newton's second law for cancel for this R. Therefore, perpendicular to R, right? We have to use Newton's second law perpendicular to R. And what is that? This direction. What is the direction? From the F2, right? Acceleration direction is acceleration direction, right? Right. This side, F equal ma for particle P, right? Particle P. What is that? F come from mg, right? Not from R, right? Only from mg, not because that perpendicular to R, no? Mg. What is the component? Mg here alpha, then this one mg sin alpha, right? Here mg, here sin alpha, here cos alpha, here sin alpha, right? Mg sin alpha. This component should be mg sin alpha. Mg sin alpha equal, that is F complete, M. What is that? M also same M. Now A is acceleration, no? A is acceleration, right? What is that acceleration? F2, right? F2 and F1, no? F2 completely, F2. F1, that should be component, right? Here F1 cos alpha, F1 cos alpha, that is this direction, opposite to this one, right? Therefore F1 minus, no? This direction, F1 cos alpha, F1 cos alpha, direction opposite, here positive and here negative, F2 minus F1 cos alpha, that should be F2 minus F1 cos alpha, right? F2 minus F1 cos alpha, that is equation 1. Then we can cut M also, M, no? We can cut M, right? We can cut. Now second one, for the system, right? We have to two equations. Why? Unknown thing, F1 and F2, no? We have two unknown item, right? Then we have two equations, right? Right. Another one, complete system. This side F equal ma for system. What is that a force? Forces? No any forces. Why? Mg downside, right? Mg also downside. 2mg also downside. Another one is, right, else upside. All the perpendicular. All are perpendicular to that, right? This here R and R cut. Why? One R here, another R here, and two R cut. No any forces. No any forces, right? 0. Forces are 0. M, two items. One is wedge, another one particle. One is wedge, another one particle, right? Then capital M. First one wedge. You can take capital M. Capital M have only F1, right? Acceleration F1. Simple M. Two accelerations here. One is, what is that one? Right? One is f1. Another one f2. f2 cos alpha. f1 here. Here, this side, f2 cos alpha. Right? f2 cos alpha. Right? f2 goes to like that, no? Component of f2 this side, f2 cos alpha, that is minus. Right? f1 minus f2 cos alpha. Right? Then we can take f1 minus f2 cos alpha. Right? Here f2 cos alpha. f1 minus f2 cos alpha, that is equation number 2. Right? That is equation number 2. Right? Now we have two unknown, then we have two equations. Then solving this equation, we can find that answer, right? Easily, right? Very easily, right? We have to find f1. Then we can find from f1 here. F2 come from here, right? From equation 1 and 2, right? First thing, place 2 here. 0 equal m and simple m, capital M plus simple m, capital M plus simple m, f1 minus simple m cos alpha f2. f2 come from here, right? f2. What is that f2? f2 means g sin alpha plus f1 cos alpha. G sin alpha plus f1 cos alpha. Right? Again, m, capital M plus simple m, f1 here. This one come from two of this one, right? M f2 cos alpha, m f2 cos alpha, then I am right, m cos alpha, this is the f2. This is the f2 from equation 1, right? This is the f2, right? Equation 1, f2 is g sin alpha plus f1 cos alpha. f2 equal g sin alpha, here minus f1 cos alpha, no? This one goes to other side, f1 cos alpha, right? Right. Now, solving this one. 0 equal, here capital M plus simple m. Another one here. What is that? M cos alpha, and minus m cos square alpha, minus m g sin alpha cos alpha, and here f1. f1 into capital M plus simple m, 1 minus cos square alpha, equal mg sin alpha cos alpha. Here sin is square alpha. Right? Now f1 equal mg sin alpha cos alpha divide m plus m sin square alpha. That is the answer. Right? That is the answer. Okay. Next one. Now suppose that alpha given, right? Pi by 4, that is 45 degrees, right? M given, M equal 5 simple m divided by 2. So that the speed of the wedge at the instant when the particle leaves the wedge is this one, right? What is that? We have to find speed of wedge, right? Then we have to find F1 and find F2, right? Initially, we try to find these things, right? F1 and F2, right? Alpha equal 45, M equal 5m divided by 2. Then we have F1. What is that? mg sin alpha sin 45 1 over root 2, cos 45 1 over root 2, and capital M is 5m divided by 2 plus simple m is same, sin square alpha 1 over 2, 1 over root 2 square 1 over 2. Then we can cut these 2 and 2 and here 2 and here 2. M also cut, then G divided by 6. That is the answer. That is the F1. F2. Find F2. F2 equal from what? Equation 1, no? Equation 1. We can take equation 1. G. F2 equal G sin alpha plus F1 cos alpha. Then F2 equal G sin alpha 1 over root 2 plus F1 is G over 6 cos alpha 1 over root 2. Then F2 equal, what is that? G over root 2 is common. 1 plus 1 over 6, 7 over 6, right? G over root 2 is common. 1 plus 1 over 6, 7 over 6, right? Therefore, that is the answer, 7g over 6 root 2, right? Now we can try another diagram. What is that? Here starting 0. What is the acceleration? F2 relative to h. And here velocity, no need. Only time, t equal t1. Which starting 0, acceleration F1, after that finally velocity v. They are also t equal t1, right? Then we can two equations. What is that? Two equations. What is that? We have to find t1 from the particle, right? Then find the v from the t1, right? That t1, right? Try that. This one pi by 4, this side s equal ut plus half at square 4 p relative to m. M is wedge, right? S. What is this? Oh, here A, no? Here A. This is the 90 degrees, and here also A, because this one pi by 4. This one should be root 2A, right? A sec pi by 4 root 2A. A sec pi by 4. root 2a equals 0 plus half f1 t1 square. Then we can take t1. t1 equal 2 root 2a divide f1. Right. Next one, this side, notice v equal u plus at for h. What is that? V equal u is 0 plus that is f2, no? Here f2, f1 t1. V equal f1 into root 2 root 2a divide f2. What is the f1? G divided by 6. 2 root 2a. What is the f2? 7g. 7g divide 6 root 2. Now we have calculation, no? What is that? We have complete calculation. G square divided by 36 2 into 2 into 2 into 6 a into 7g. 1g is cut. Here 9 and here 2, here 3, no? Now we have 2ag divide 21. That is the answer. Very simple, no? Very simple. Right. Very simple. Why? Calculation also not difficult, no? Why? Very simple. This is the 2014 examination question, but that is not difficult, right? Because this one have only one wedge, right? Now new syllabus, your new syllabus have combine wedge and pulleys, right? Next video, I will try to explain that pulley questions, right? Another one, any you have any suggestion? Please comment that, right? And subscribe our YouTube. Because of that, I will try to more than 300 questions, past papers, right? I will try more than 300, right? Then you can understand what is the combined maths easily, right? Right. Any questions? Please comment that. Any suggestion? Please comment that. And keep in mind, subscribe our YouTube, right? Okay. We will meet again. Ayubowan.